Recordings in progress. Good evening, y'all. It's August 1st, 2023. I'm your host, Jordan West. This is Platoon, Platoon, evenings and weekends. Week 10, day 2, SQL schema design. We're going to build a blog. This is not significantly different from what you've done yesterday. We're adding a little bit to it, but I think it's great good practice to kind of talk about SQL designs, kind of build out how you want to think about databases. Don't ever feel bad if you build a database and you start building your application and you realize you ain't got enough tables, you did something silly, or you did something weird. That's all part of the process. But the more you do it, the better you'll get about it, the better you can visualize your data. And the better data structures you'll build, the more efficient they'll be, the more sense they'll make, the less replicated data you have. We try to keep it dry. You might hear me complain about the comments row here in a bit, comments table, sorry. I will complain about it. However, it is very dry. It does not repeat itself. In fact, it is recursive in its use. It duplicates itself, which is real cool and real fun to query, which we'll show you now. Today, using BlogDB. If you want to follow along, you can click on this link. It'll open this up here, take you to blog-db, which is a repository. You can see the cars database for reference, but pretty much you clone this down, run setup.sh, located here, should be executable. If it's not, chmod it. Interacting with the database, we can go look at cars database to see the individual interactions. We won't really be doing that too much in this course, in this lecture here. So I've got it open right here, cloned it down, BlogDB. I'm going to run setup on this setup shell. It's going to docker build, docker run, sleep, and then docker exec some, basically it's going to init this database for us, which it probably already has done because I am a good instructor and I did this ahead of time. It'll run a little bit longer on your machines, not much longer though, it's pretty quick. This is that 3-second sleep, and now we get into it. Database is open, it's running, it's initiated, instantiated, instanced. So what is a blog? This interacts, I haven't seen, the only website in my head that's like, I don't know, Facebook kind of does this, but Facebook kind of uses a reply kind of thing. I know, and sorry, I'm a loser, but I do spend a little bit of time on Reddit here and there, video game stuff specifically. They have comments that are attached to comments. They're not always associated with the post. They'll be associated with a comment, and they kind of branch out this way. That builds a tree, kind of like this sort of thing, if you know what I mean. That's what we're going to be doing here. You're going to have users, you're going to have posts, and you're going to have comments. And that's not where it ends. You can comment on a comment of a post of a user. It doesn't necessarily all need to be associated. We're going to kind of trim the fat there, but that's what we want to construct here. How would I do it? A less dry method, maybe. I would require another table if I wanted to do that. And I would do something like comment underscore comment, maybe. It sounds a little silly. Pretty easy to query that and pretty easy to build that out. It does give us an extra table. Doing it this way, we'll save a table. And it makes the querying a little bit more complicated, I think. However, it is more concise. And it doesn't really make a lot of sense to duplicate rows. Yeah, I would do probably a join table is the way I would do that, but we're going to do it this way. How should they be connected? I just told you all, but it's going to be all one-to-many. So a post, single blog user, and a blog user can make, it should be made by a single blog user. A blog user can make many posts. That's the one-to-many relationship. A comment should be made by a single blog user. A blog user can make many comments, one-to-many. A comment can belong to a single post, and a post can have many comments. That's your other one-to-many. And then last but not least, a comment can belong to a single comment, and a comment can have many comments, one-to-many. Do we all track that? Does that make sense? Is that how websites work that you have interacted with in the past? That's good. And something is, I don't know why I'm going down this path, but my attention deficit disorder is a big part of designing websites, y'all, a big part of UX, UI, things like that is designing what people are familiar with. Just, you might have a better way to do this, you think, than this. You might say, hey, this is silly. I've got a better way that people should talk to each other. It might actually be better and more efficient, but people are used to certain things. That's why when someone goes to Amazon.com or any website really, and it has a burger menu, do we have a burger menu here? Well, these ellipses. Here we go. There's a hamburger menu right here. Do y'all want to know what this is supposed to do conventionally? Nobody knows what it's supposed to do conventionally. It's just supposed to exist because people know it exists. This does different things on every single website you ever go to, even though it always looks like this hamburger here. Little piece of UI, UX trivia. Put one of those on your website because people want it. That's why it exists. Back on track. This last one is a bit tricky since definition is recursive. But as you see here, post is going to have an ID, everything's got an ID. We can ignore that. A post is going to have a user. We don't really have our user ID set here, but that's not necessary. It'll kind of be generated by the application that's doing it. I think we're just going to feed those in there. There is no, there's not any specific table for users. We've just got IDs. That'll be provided somewhere else, not really logged here. Posts have titles, they've got text. Blog users, which do have a user ID. Sorry, y'all. User ID is blog user. Oh my Lord. Names, email, that's the stuff we want to keep. Comments, though, this is the most complicated of the two. Post can have it's got to have a user, it's got an ID, but it exists beyond that. It's only associated with its single user, which there could be many posts. But this comment, it's gonna have an ID, it's gonna have some text, easy peasy. But these other three things are all going to be related to something else. The user ID is going to be a blog user. Its post ID is going to be a post. And its parent comment ID is going to be another comment, the primary key from another comment. How the heck do we do that? It's like this. So let's talk through this just a little bit. Better yet, I'm just going to ask you all, because you all did this yesterday. Philip, what's going on with this table? Explain this line by line to me. Just this one.
So it looks like we're going to create a table blog user, and then it's going to have an ID that's going to be a serial primary key type, which will increment. And then it'll have a name with varchar, so like a string set to like 100 characters or something like that. And then an email with varchar of 255 and then not null. So yeah, the table should get created with just those things.
What's not null mean?
Like not nothing or like not empty.
So does that mean if we were to create a table, what things does it need? What things does it not need?
You mean like could we leave name empty and then just as long as we give it an email, I think the primary key will be generated for itself.
Yeah, that's right. That's it. Harry, I want you to talk through this one.
Okay, so we're creating another table with a primary key. I'm guessing somehow this table, I'm trying to figure out if this table is communicating with the first one.
I don't know. How would what part of it would be interacting with the first one?
I don't see blogger user ID.
There you go. This is usually okay. Your key there. So what does this mean if you were to read this in English and explain to somebody who doesn't understand SQL?
That these tables are communicating with each other.
So if I were to create a new post, it's got a row called user ID. What is user ID referencing?
User ID, it's the first thing on the blog user ID, that serial primary key.
That's right. That's just saying when I create a post, it's going to have a user ID. That user ID is going to reference one of these blog users. Yeah, exactly. What's this? Why am I using varchar here?
And then that's a good question. The last one, the other one, title biochar, like 255 characters. You have to put on a title all the time, otherwise it wouldn't work, right? That's what not null it's gonna mean.
That's correct.
And then text, why does it look red? And I'm guessing like you only can write like a text like in that one, like essentially because it's a post, a text is essentially what they put in the post.
So varchar is best for short to medium length, while text is better for super long or large amounts of data. I forget the exact amount off the top of my head. That could be it. If we're talking MySQL, it might be about the same in Postgres. Basically, text, when you use the word text as the table type, we're setting the property of this table, that's saying basically the same thing as varchar, but it goes up to like a massive amount. There are reasons.
There's no limit on text.
There's no limit at all?
No, that's what I just read right now.
So someone can write a very like Python script with a bunch of infinite loop of text and crash the thing, maybe. I don't know.
I
maybe
guarantee you it will eventually not
It says
take that
up
in.
to a gigabyte of data. Sorry.
Okay, yeah. So that sounds right. I've definitely put in too much in text before, but it does depend on versions, things like that, which type of database. But yeah, text is basically if you're expecting them to write a ton of free form, whatever the stuff. Varchar is kind of reserved for like data, like properties of the thing that you're talking about. Like a user's name would be a varchar, email, God forbid, social security number, stuff like that. Stuff that's kind of limited and expected in small amounts. If you really don't know the size, it's okay to go text. But we do want to use varchar for kind of smaller things. 255 is kind of I think both the default and the max. Maybe I think you can do sometimes you can make a varchar a little bit larger, but we're getting to the minutia of that. Why this is red? That's probably because this interpreter here is reading SQL and text is a reserved word. So it's just highlighting that, seeing it in SQL. Even though it's not capitalized, it's not smart enough to say, oh, it's over here on the left side. It's just seeing a reserved word. Like these. Last but not least, who wants to take a stab? I'm going to ask for a volunteer this time. Who wants to take a stab at reading this line by line? What's going on? Ooh. Y'all know what Navy stands for, right? Never again volunteer yourself. You ever hear that? All right. Ken, take a stab at it. We're going to work through it together.
Dang it, I knew what that means too. I mean all the stuff in the beginning, like the ID serial primary, just like a number that generates, text, we just went over that.
Yep.
It's really when it gets down to the check is the
well, stop here because I want you to read me this one. Maybe
All
it's
right,
not that complicated, but I do want to talk about this line because this one's important.
Oh yeah, so that one I guess is the beginning of the confusion, I guess. So that references the ID within the same table.
Yeah. But keep in mind, this is just an instance. This is not referring, when I'm saying this, that's not referring to this table we've created called comment and its ID. We're referring to an instance of that table, right? Like when we've done object-oriented programming, this isn't saying, yeah, you need to refer to all the comments ever. It's nothing like that. It's just one specific comment. So this is kind of recursive in its building, but really you're just referring to another comment ID, right?
And I guess the check is just kind of maybe like a SQL's version of like a conditional statement or something.
Yeah, conditional statement. I think when you get into data, the word, oh, brain, don't fail me now. God, we're gonna get into this with Django. Validations. I think it's a validation when you get into like database checking. That can be done on SQL side. Often it's not. Often you try to catch a lot of this on the Python side if we're talking Python. But yeah, cool, optional. These kind of make sense a little bit. If a comment, excuse me, post ID is not null, meaning there is post ID, and a parent comment ID is null. So that means we don't necessarily have to have a post ID, but we do need a comment ID. So there is a nullable post ID here, right? This is not null, but we're kind of setting it here. So it's kind of reverse. Basically, what this is going to allow us to do is a comment is either going to have a post ID that is null or a parent comment ID that is null. If it is the first comment on a post and it's not a comment of a, well, basically, if it's not a comment of a comment, it's not going to have a parent comment ID. It's going to have a post ID. And if it's a comment of a comment, we don't really need the post ID, evidently. We can get that from its parent comment ID, which it will have. So to query that backwards, and I can mirror this out if you guys want to. If I were to look at a comment of a post, and I want to know I want to know something about that post, I would need to say, hey, comment, what's your comment? What is your parent comment ID's posts something? You would go upwards one more. So if it is a comment of a comment, you reference its, parent comment to go above. If it doesn't have a parent comment, you go straight to the post. That's kind of what this check is doing for us. Again, it is optional, but this is kind of a really smart way to do this. Basically, it's saying, hey, either post ID is null or comment or parent comment ID is null, but I don't want both of them null, and I don't want one or the other null because that kind of is going to get us into some trouble. I don't want someone to be able to create a comment that is not a child of a comment and is not a post either. If we didn't have this going on here, you could get some janky bugs like that. You could have a zombie comment laying around. It's like, I don't have any parents. I'm just chilling. And it'd be like smoking cigarettes behind the school, stuff like that. Like, that's not what we want. I'm trying to avoid that. No orphans, no zombies. That's what this is allowing us to do. Otherwise, we have a comment that could very well break your code when you try and look something up. It's like, oh, I don't have a dad. And, am I getting way too ephemeral about this? What's going on?
So just to clarify, on the front end, you would code it to where if someone was to comment on a comment, it would not populate the post ID. It would almost leave it blank.
Yes. Well, it would allow,
Okay.
yeah, it would leave it blank. So just like blog user, it needs an email, but it doesn't really need a name. The front end is going to submit a form. Well, really the way this works, but back end and database are also kind of separated, but you can think of them as the same thing. Front end submits a form. It says, hey, give me your email. If you want to, give me your name. I submit just an email and I fire it off. Back end takes that and probably has some validation of its own saying, hey, I want to create a new table, I want to create a new blog user. You just gave me the email, smush it into the database. Database looks at it, populates a primary key, plugs that email in, and then for name, it just goes, null, doesn't have one. And that's fine. What this is doing for us is making sure that God, for whatever reason, because let me back up to the first one. If I were to submit a form on the front end and the front end didn't catch it and the back end didn't catch it for whatever reason, I said, no, heck with you. I know it says it's required email, but I'm just going to give you a name. And we pass that in. either the front end doesn't catch it, back end doesn't catch it. Database for sure is going to say, no, that name is fine, but I need an email. And that's because the database is protecting itself. For this comment, all these comments have to have a parent. Because how are you going to populate this stuff? If a comment is ever created and it doesn't have a post associated with it or a comment associated, above it, and you try to query all these on the front end, I don't know what it's going to do to your website, but you're going to have a dead comment laying around and it's going to break something. Most likely what would happen is it's just not going to show up on the front end. So people are going to comment on something for whatever reason your application is not giving it a post or a comment associated, and it goes off in la la land and it's gone forever. That'd be very hard to track, right? You would be submitting comments and you would not be able to see them on the back end or the front end, but the database is getting them. That's what we're avoiding here. We're making sure that everything has parents so that we can query down to it. Because by nature of our blog website, we're not just showing you every comment that ever existed. You're going to go to a post and look at the comments. Because a comment by itself is kind of pointless because a comment has to have something it's commenting on, right? Otherwise, that's a post.
And when
Queries.
those checks, Jordan, is it what was I gonna say? Does that affect, I guess, performance if you have it check on like the front end, back end, and then the database, or is that like usually best practice?
It should kind of be happening everywhere. So there's different reasons for it, right? The database would set restrictions to protect itself from getting broken. That's generally what it's worried about. Backend, kind of similar situation there. But backend is going to have more like context, right? Your database only knows about these tables. It doesn't know anything else unless you want to get real hot with your SQL and program stuff in there. Maybe let's say you're a free user, and on squid.com, free users only allowed 5 posts before they have to get paid membership. So how would I do that? Does the front end know? Not really. The front end would have to pull that information because that's stored in the back end. The front end is just the interface. That's the DOM, things like that. So when you go to put that 5th post or that 6th post in there, the front end wouldn't catch something like that. It would pass it to the back end. And the back end would have your user, your number of posts, and it would be able to run some logic, Python per se, and say, when you're creating this table, if post count less than 5 or less than equal to 5, submit this to the database. If not, return error, things like that, or something like that, right? That's why that's the kind of check you do on the back end. If you have requirements for an email, like an email needs to end with @.com something, right? That would be silly to do on the back end because what's the feedback loop there? You submit the form and then make the user wait until there's a success. It's gone into the database, returned back, and then gone forward. Like performance aside, that's a silly way to do that. It's going to slow it down even when it's working properly because you're going to submit a form and it's going to have to fire off the back end and your site's just going to sit still, right? Because what are you supposed to do? Or are you going to tell the user submitting form, checking with database, there's a problem. That's not what we want, right? If I put in a fake email, I want it to click right then and there and say, hey, that's not a real email. That's the kind of stuff you check on the front end. So you're looking mainly syntax issues, quick user feedback issues, anything like that, required fields not being caught. That's a front end kind of validation. Anything deeper, app specific, such as like limiting the number of posts you're allowed to make, verifying there's no like naughty words or something in your that's probably better on the front end, but basically things that you don't want to mess up your app on the back end at an app level, like at a beyond the scope of the data, like things that my app knows, right? If I've got a blog user that's only about Pokemon stuff, how the heck am I going to tell my SQL database, hey, only posts that have Pokemon, content in them, nothing about Crash Bandicoot, right? SQL's not going to be able to catch that kind of thing. That's not a validation to be able to do. Backend would probably look for those sort of things. Say, hey, this post came through. It doesn't really have any naughty words or anything in there. Everything seems right, but it's got stuff that we don't really want to keep data on. Let's kick that back. I'm giving a few different examples. Y'all picking up what I'm putting down? Smell what I'm stepping in? Does that all make sense? Y'all disagree?
Yeah, that sounds good.
Okay, cool. That's definitely something when you're kind of getting into it is like, why am I validating this here? Why am I just going to validate it at every step? It's like, well, no, you don't want to. There's some things that make sense to do here and make sense to do there. You could just do it all on one side, but for efficiency is definitely one of the reasons. And also, I don't know, just where that data is being solved, where those problems are being caught. You don't really want the front end to have to do all this heavy lifting of querying the database and stuff like that. That's better for the back end to handle, because you don't want to pass data too much. It gets slow. Queries. We did queries yesterday. I'm not going to make y'all volunteer and walk through these unless we need to slow down a little bit. I'll just kind of walk through them. So how would we query a schema like this? So what is the name of the user with the most posts? That's a reasonable thing to query. I probably want a count of a user's posts, and I want the one with the most. So we're going to select count star blog username from blog user, and we're going to join that up on posts. So for every user, this is the where, this is the logic here, where for every post user ID that belongs to each of these users. So we're going to be taking a count and locking that to a user. Group by username. So this is what I want to see on the table. I want to see account and I want to see the users' names. And we're joining the posts and the blog users on where they meet up. Basically, for the user, I want all of his posts. That's what we're looking at. That's the table we're building, and we're going to order these by that count, like the total count, and we're going to limit it to 1 in descending. So it's going to start at the top, descend down. We're only going to get 1. That should be count 7, name Jimbo. Jimbo has the most posts according to this. Does that work? Oh, wait, not that part. There we go. Did I mess up? Did I copy too much? Oh, what's going on now? Name. There's error here. Count. That work it all up. Find the wrong thing. Oh, there we go. What was going on? I must have had a hanging. I must have had something hanging. I'm sorry, y'all. Yeah, so as you see, this goes through there, finds old Jimbo. We could adjust this if we really wanted to see kind of specific things. Shoot, let's see the top 3 counters that are top 3. That's an easy thing to do. There you go. It is indeed descending. It is showing you the number of the users. We could what else? I mean, I guess that's fine. I guess we can do their email as well. Email. Oh, it's not called email. Yeah, it is. What did I mark up? Oh, I had to fix it in more than one spot. Sorry, we'll get through this real quick. If I could set them as my interactive shell on this, we'd be in business. Yeah, cool. There it is. We did the exact same thing. We just went by their email instead. That makes sense to everybody? I fiddled with the query to kind of make it do different things. What are the top 3 comments with the most comments? So this gets a little bit more complicated, but nothing crazy. As we mentioned before, comments can have comments. So rather than having a separate table called like comment children or something, we're going to reference a comment above it. So again, we're going to get a count oops, we're going to get a count of, and again, y'all will hear me complain a bit about this shorthand because I think it's hard to read, but I'm not used to reading it. So who's to say? Y'all can decide if you like this. Select count. What are we counting? Kind of ignore this for a second. Comment ID, because comment is C1. So comment ID as comment ID. Goodness gracious. So we're getting comment ID, which is going to be the original comment C1. It's all, we could have just select comment ID, join it on comments, which is all the other comments, C2. So join the comment IDs on their comments, or with comments, sorry, where C1 ID is equal to C2 dot parent comment ID. So where a comment ID matches another comment's parent comment ID. That reads weird, but do y'all understand what this is saying now that we've gotten to this line after these? Is anyone not caught up here? It's definitely okay to say I don't get it because that is confusing. We are going to group it by the first comments ID, and we're going to order it by descending count. So we're going to look at all the comments. We're going to look at all the comments with comments, and we're going to join them. Whichever one, which is a many-to-one relationship, has the most is going to end up on top because we're doing descending order by the count. So we're getting all the comments. We're pulling up all the comments again, but every time a comment has a comment ID, we're joining it onto that comment. So, you know, a comment that doesn't have any comment IDs is going to be much like this was the user before. You can think of parent comments as what we're joining on, or the final, you know, what we're getting counts of, and its count here is going to be the number of comments it has. So comment ID 2 should have 12. Comment ID 60 has 5. 81 has 3. Hard to validate that. We're going to go ahead and try. Looks right. Looks the same. Are there more? Yeah, that keeps on going. That descends downwards as we'd expect. How? Let's see. Don't want to make this more complicated. Let's go down to the next one. This is kind of what I was going to try and work through, but it gets silly. So as mentioned here, don't worry about this. This is an advanced query. This is beyond Jordan's skill at SQL. These are things I call my buddy Alex for and say, please help. The students are going to find out I don't know SQL as well as they think I do. Let's walk through it a little bit. Don't worry too much about it if we get a little bit lost in the weeds. I'm going to get lost in the weeds, and I'm recording myself looking stupid, so don't feel, you know, don't feel bad if you need to stop me and ask a question. So we're going to select blog user name. We want to get, again, name of the user with the most comments. From blog user makes sense. Join. What are we joining? We want all the comments. For the comment ID, select max comment ID from. What is max comment ID? Well, we're establishing it down here. Yuck. Get a count of all of those comment IDs. So this is looking a little bit like this, right? This almost could be copy pasted right here. In fact, I think it is. And we're limiting by 1. Yeah. So basically, what we just did is right, kind of going on here. For a user, get all the comments and all the comments that are, you know, children, and load them up. Basically count all of them, though, I think is what we're ultimately doing. No, sorry, we want the comment with the most comments. So we're running the same query again. We're looking at all of his comments and trying to figure out which ones have the most comments. So running this query is nice, but we're not just running it for all the comments. We're doing it for the users, which is why we're taking users from up here. So we're joining all the users with all of the top comments and comment IDs, and then we're going to basically descend that list. So we're taking all the users, we're counting up all of their comments of comments or comments on their comments and counting those up and then putting them in order. It should be Leo Dara, but we're not really seeing the count there. So that does work. I would like to also see their count. Or sorry, not just their name. What is this count here? How do I get that count? X. Oh, that might be breaking us up there. I kind of want to see their number. But again, this is beyond my dad going. I wonder what happens if I get rid of that X. What do y'all think? I bet that breaks it, huh? Yuck. We're not going to deconstruct that real time. Again, this is a kind of complicated query. What I need to figure out is what I want to get from this data was the number of comments on that comment. Okay, I understand why that gets more complicated then. Getting the comment and then taking its count is probably a better idea. Actually, we probably don't have to look that up. I guarantee it's comment ID 2, isn't it? It's probably got 12. So we already did that work. That's okay. That's why we're not reversing it. But yeah, the comment that has the most comments is comment ID 2. I bet Leodara owns that comment. You could do that query though. Select blog. I want to do this real time, but I kind of want to also. Get all the comments from comments, where comment dot user ID, right? Comments have user IDs. Equal to oh, they're not foreign, they're foreign key. Ooh, we'd have to know what Leodara's is. What did I do?
You need single quotes.
Oh, where's that? Oh, goodness. It's made up.
Number 2.
Well, interesting. Oh, it is 2. Oh, so users 2, common IDs 2. Fun. All right, that's fair.
You spelled it wrong. It was
Did I really?
yeah.
Oh man, Leodora. Hey. All right, we're not gonna keep fighting with that. Anyways, queries are cool. Does anyone have any questions?
Hey,
Who said that? I think it was Philip. Walked away and he's hot micing. All right, we're gonna stop recording.